we need to solve this logarithmic equation. So quite a lot of logarithms going on here, so I need to use the laws of logarithms to group them together. So on the left-hand side, I'm going to use the multiplication law to combine these two logarithms together. So I can write log base 2 of the y multiplied by the 3y plus 4 is equal to, now on the right hand side there's only the one single logarithm, but it does have that coefficient of a 2 in front there that I don't particularly like because I didn't have a 2 on the left hand side. So I'm going to use the power law to move that up to be a power there. So the right hand side is the same as log base 2 of 3y minus 4 squared. This now allows me to do 2 to the power on both sides because these are inverse functions and are going to cancel out. And similarly on the right hand side, those are inverse functions and they're going to cancel out. So on the left hand side I'm left with y times 3y plus 4. On the right hand side I'm left with 3y minus 4 squared. Expanding these brackets, and making this equal to 0 by subtracting the 3y squared from both sides and subtracting the 4y from both sides. I can make this quadratic a bit easier to solve by dividing both sides by 2. And I can now factorise this. Like so, because the 3y times the y gives 3y squared. The minus 2 times the minus 4 gives plus 8. And then checking the middle term, the 3y times the minus 4 gives minus 12y. The 2y times the minus 2 times the y gives minus 2y. And we can see the minus 12y and the minus 2y do give me the minus 14y. So that has been factorised correctly, which allows me to see that my solutions for y are either that it's equal to 2/3 or 4. But I do just need to double check that to make sure they're valid solutions for the quadratic, but are they valid solutions for the logarithmic equation? So what I mean by that is, if I substitute 2/3 in instead of the y here, here and here, do any of those become negative? Substituting the 2/3 in here, that's fine. If I substitute the 2/3 in here, I get 3 times 2/3 plus 4. So that's going to be positive, no problems there. But if I substitute the 2/3 in here, I get 3 times 2/3 is 2, minus the 4 is minus 2. And I can't do log of minus 2, that's not defined. So this is not a valid solution for this equation. It is for the quadratic, but not for that logarithm. Let's just double check the 4 now as well. So if I substitute 4 in there, that's fine. 3 times 4 plus 4, that's going to be 16, so that's positive. 3 times 4 minus 4 is 8, so that's positive as well. So yes, y equals 4 is a valid solution to that logarithmic equation.